Okay, we're going to draw an ogive now of the taxi fare data and use it to calculate some percentiles and the interquartile range. So ogives come from cumulative data, so what we have to do is first of all complete a cumulative frequency column. There were 2 fares of between $0 and $10. Then there were 9 fares of between $10 and $20. So if you kind of put them in order of size, after we've counted the first group, we've counted 2. Then after we've counted all the fares between $10 and up to $20, there were 9 there, plus the 2 we've already counted is 11 in total. There were 5 more fares in this group. In total, 16 were below $30. Then 4 more in this group takes us up to 20. 2 more in this group, 22, and then 24. That's a cumulative frequency column, and that allows us to draw an ogive. Along the bottom of the graph, I'm going to put the fares. So let's go from naught. I'll use 2 squares as $10. Fits nicely. And up the side, each square will be 1 count. That'll get us up to 24. 1, 3, 4, 5, 10, 15, 20, and we've got to get up to 24, so that will fit nicely. It's often best to draw a cumulative frequency histogram first and then just try and fit your ogive inside it. So from 0 to 10 we had 2, and then from 10 to 20 we had, by that stage, counted 11 scores. So that will take us up to 11. By the time we finished the next group, we had accounted for 16 scores. The next group took us up to 20 scores. Then 22. I'm just doing this a little bit roughly. I'm going to try and make my ogive quite accurate, though. This is just really to tell me where to place my ogive. And then up to 24 scores accounts for all of the fares that the taxi driver took. Now, the ogive fits neatly inside there, so I just connect the starting point and then just keep on connecting to the top right hand corner of my cumulative frequency histogram. And there we have it. That's my ogive. Now I'm going to answer some questions. The first one is find the 25th and 75th percentiles. Now we need to define this. It's a good idea to have a percentage axis. The percentage axis I'm going to put on this side of the graph. It starts at 0%, and don't forget to label, this is cumulative frequency. This is going to be cumulative frequency percent. Starts at 0, and the last score accounts for all of them, so that'll be 100%. Now what I have to do is divide this up neatly into percentiles. I'm going to mark the 50th percentile, which is the median, the 25th percentile and the 75th percentile, which can be interpreted as the lower quartile and the upper quartile. Now one way you could find them would be to get your ruler and measure the distance between 0 and 100%, and then just mark off the middle. That would be 50%. Then measure that distance divided into half, and divide it into half, and you'll have your 25th and 75th. This particular one is a bit easier in actual fact though, because it went from 0 up to 24. So I can find the middle easily. The middle from 0 to 24 is 12, and so that means that if I just go straight across here from the 12, that'll be my 50% mark, and then I could count the squares up and divide them in 2, or I could just go straight across from the 6. That will divide that up into 25%, and then if I go up another 6 squares, 1, 2, 3, 4, 5, that will make me 75th percentile. Okay, now how do I actually find, I've got a percentage axis on there, but how do I find the 25th percentile and the 75th percentile? Well, I go up to 25%, go across to my graph, and then go down, and I come up just a smick over 15, let's say 16. And what does it mean? Well, 25% of the data is below that amount. So that means that 25% of the taxi drivers' fares were below $16. What about the 75th percentile? I'll mark this axis here to 75%. I can go across to the graph and go down. Yeah, you need a bit of accuracy here. That one seems to come out to about 36. That means that 75% of the taxi fares were below $36. Now, the 25th percentile is effectively the lower quartile, and the 75th percentile is effectively the upper quartile. So if you want to find out the interquartile range, you can just take one away from the other. I'll just move my page up so that you can see what I've been writing. Okay, so if we want to work out the interquartile range, it's equal to the upper quartile minus the lower quartile, or the 75th percentile minus the 25th percentile. 36 take away 16, that's an interquartile range of $20 in this case. We have already done this exercise by another means actually. Can you remember when we did the stem and leaf plot? We worked out the interquartile range for the taxi fare data. What did we get before? Well, interestingly, it's not exactly the same. We've got an interquartile range of 19.5 compared to 20 here. We found we had a lower quartile of 17 and an upper quartile of 36.5. We're pretty close on the upper quartile. The lower quartile of 16, there's a little bit of difference between the two there. Now I would put that difference down to a little bit of inaccuracy there with the graph. you may also get a few differences. Here we're dealing with actual data. Here we're dealing with graphical interpolation, and I would tend to say that the actual data is slightly more accurate than doing it this method.